This set of videos would be for September 8th or September 9th. And we're looking still at graphing and transforming the sine and cosine functions, and we're looking at key features. Today, last class we looked at moving left and right, up and down. If you didn't do that already, go ahead and revisit that. Those notes are from August 31st. Is that right? No. September 2nd and September 7th. Go ahead and revisit those, see if you can work through those before doing this. But here we're doing -2 times cosine of x. We're going to plot the points, see what's happening. Hopefully something changed, and notice what changed. So I'm going to say let's use the x value 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so I'm going to go ahead, because a lot of people struggle with 3 pi over 2, I'm going to go ahead and do this one, and then I'll just figure out the ordered pairs. Alright. So we can plug 3 pi over 2 into our function. And when we do that, we get cosine of 3 pi over 2. Either looking at the unit circle or the parent function. For cosine, cosine of 3 pi over 2 evaluates to be 0. And -2 times 0 is 0. And so our ordered pair would be 3 pi over 2 and 0. Now, what I would recommend doing is to pause it, see if you can do the other 4 rows on your own. If you don't pause it and just like, I don't care, give me the information, not the best mindset, if I can, but the order pairs here would be 0, -2, 0, 0, or sorry, pi over 2, 0, because our input would be pi over 2, our output would be 0. Pi and 2, 2 pi and -2. Alright. So now let's go ahead and label our axes. So 2 pi, pi, pi over 2, 3 pi over 2. Similar thing in the negative direction. Alright. But here we have to look at our y values. Our largest output was 2, and our largest output was -2. So let's call this 1, 2, -1, -2. Whew. Now to see the transformations, I'm going to go ahead and draw the parent function. If you don't want to do that, that's fine. But since it's cosine, we quote unquote start at 0, 1. And then our function behaves like this. And we could go in the negative direction. I'm just going to do that. And now let's plot the other points. 0, -2. Pi over 2, 0. Pi and 2. 3 pi over 2, 0. And 2 pi, -2. And so our function looks something like this. So this is what our function looks like. Now in class we had a good discussion, really good discussion actually in all classes, about what changed. What changed from our parent function to our actual function. And what we decided is first, here it was positive and then turned negative and then positive. But on our actual function, it went negative, positive, negative. And so we said something changed here. We actually had a reflection. So that's one thing that changed. And if we look here at our function, our actual function, the reflection comes from this negative value. Or in other words, if we multiply our parent function by a negative, that's going to cause a reflection. And if we looked at key features, our domain stays the same. It goes from negative infinity to positive infinity. Our range changed. So I'm only going to write the things that changed. Our range, our lowest value in y is -2. Our largest value for y is +2. So that changed. And our amplitude changed as well. So now our amplitude, if we measure the distance from the middle of our function, which for right now is 0, to the height of our function, or the bottom of our function, so this height is 2. This height here is also 2. So our amplitude became 2. And our period didn't change. We said our domain didn't change. I'm not going to write that though. So what's happening here is, if there's a negative value, if we're multiplying our parent function by a negative value, it's going to reflect. However, if that value is also, depending on the value, if it's not 1, that's going to dictate our amplitude. So because we multiply it by -2, the absolute value of -2 is 2, that's our amplitude. So for example, I'm going to go down here. If you want to pause, take further notes, rewind, that's fine. Here, if it was just +2 cosine of x, it would be this one would be the exact same here, but there would not be a reflection since it's not negative. If it was 1/2 cosine of x, there would be no reflection since the 1/2 is not negative. And our amplitude would equal 1/2, because that's the value multiplied by cosine of x. Similar thing here, no reflection. And our amplitude is 2. Okay. So that's what's happening when we multiply our parent function by a value. We multiply by -2 here. We reflected and the amplitude changed. Here we multiply by 2, our amplitude changed, no reflection since it's not negative, and similar thing here. So maybe if you want, I'm not going to go through this definition. Let's see if we can figure it out. If a times sine of x or a times cosine of x, I'm going to just give it to you. A is going to be our amplitude, but we have to be sure that we take the absolute value of a to make sure a is going to be positive. That's going to be our amplitude. And if a is less than 0, then we reflect across the x-axis. If you want to make this a nice complete sentence, that might be good. Same thing here, but that's what's happening. And we'll see practically what this looks like in the second video. So if you keep going through these notes, second video, we'll go through some practical application.